Ed, in your role as VP of Manufacturing for the RG Group, you are responsible for the actual fabrication and ultimately the installation for the Navy project. Could you give us a little bit of an understanding in what challenges that may have presented to you and our manufacturing capabilities as you built what is a fairly unique project?
Sure. The first challenge was the sheer size of this system. It was one of the larger systems we've built, 600-gallon reservoir, 2 500 horsepower motors, very sizable power unit, 6 cylinders, 6-inch bore cylinders with 8-foot stroke that had about 20 feet of cylinder in motion times 6 on our floor. So it consumed literally half the production shop. Additionally, the power requirements were quite large. It used just about every one of our manufacturing capabilities. We had metal cutting and fabrication, welding, system assembly with some very large components again, utilizing every bit of our 10-ton overhead cranes. We did marine-grade epoxy painting, large hose assembly, 2-inch hoses, high-pressure, high-volume hoses, very sizable bent pipe spools. So engineers and project managers and control specialists, even Navy brass had to have access to our facility over several weeks of performance testing, which means that we had to step up our housekeeping and security. Flexibility really is one of our core strengths. We can open the shop up to a very large project like this at the same time. In other areas of the shop, you're working on several small projects at once. We can set up flexible manufacturing cells to accommodate high volume of product. So certainly that flexibility allowed us to take on a project of this size and gave the customer fairly significant comfort with our ability to get the job done.
Dave, I know you were the lead engineer on the project that we recently completed for the Navy. I know there was a lot of nuances to what needed to go on in that design and basic manufacturing and installation. So give us a few highlights or challenges of that project from an engineering perspective, if you could.
Okay. So based on the first round of calculations, we determined that the system was just too large for the capacity of the ship that it was going to be placed on. So we had to do some redesign, and we decided to go back to a smaller size cylinder to reduce the flow requirements, thus reducing the requirements from the HPU itself. Even with doing that, it was still too large, so we determined to offset some of the horsepower requirement with stored energy accumulators. The one thing the adding of the accumulators did was to add weight to the crane structure itself, which reduced the lifting capacity also. So we had to come up with a balance between all those factors to determine the actual system that we ended up with.
And along with the design work that we had done for the Navy, and of course the manufacturing of the HPU, one of the other elements of this project, which was somewhat unique, was we actually did the final installation and commissioning of the system. Tell us a little bit about what that meant, what resources we needed to devote to that, and how that ultimately played out.
Sure. The installation might have been the most challenging part of this entire project. It certainly, I think, was one of the most fun parts of the project. We had to be completely self-sufficient on a Navy vessel for a series of weeks to do a wide variety of tasks. Hose making and hose crimping, very large hoses, fabricating of brackets, welding of brackets onto the structure of the ship itself. Just keeping warm was one of the challenges. We did this installation in the winter, on board a Navy vessel at port in the Chesapeake Bay. So that certainly was a challenge itself. In order to do that, the RG Group procured a vehicle, an enclosed trailer. We set it up as a mobile workshop. We had to modify that trailer so that it itself could be lifted up onto this Navy ship, secured down and reside there for several weeks. So once we got over the logistics of how we were going to support this installation, we actually had to do the work. So we put several crews of guys on board, service technicians and engineers for a period of weeks, actually installing this large system, the power unit 60 feet up in the air on the top, highest most part of the crane. The cylinders were down at the end of the crane, the working head of the crane, and yards and yards of interconnecting hose and tubing. Every bit of that had to be checked and double checked. The Navy was adamant that we couldn't have oil leaks on their decks or in the Chesapeake Bay. To that end, we did full system testing on board the ship. We pressure tested every line, torque set every screw, every fastener, double checked everything to make sure that at system startup there would be no leaks on this system, no oil at all on the vessel surface. So we did the installation, we did the final checks, and finally we had the engineers on board to support the system startup, which, as we all know, went very successfully.
Thank you very much, Ed. Appreciate it.